to start today our discussion on chemical quantities. And you're probably going to want to take out your periodic tables. We're going to be using them throughout the day today. But we're starting out with the relative atomic masses of an element. Masses of atoms measured in grams are very small. If I were to measure the mass of an oxygen-16 atom, it would be 2.657 times 10 to the negative 23rd grams. We don't have a scale in Salina High School that's going to measure that small of a number. So, scientists have created a standard measurement that is constant, and it is the same no matter where you're at. It's the same in Europe, it's the same in France, it's the same in Russia as it is here in the United States. So, a standard measurement. In order to set up a scale, we have to signify one element that is the standard so we can compare all other elements to our standard. So we have arbitrarily chosen one element to be our standard, and that element is carbon 12. So the atomic mass unit, which we abbreviate AMU, is exactly 1/12 the mass of a carbon 12 atom, or 1.660540 times 10 to the minus 27 kilogram. Yeah. So, we've now set our standard, okay? We've set our standard. Carbon 12. Carbon 12 is our standard, and what is one atomic mass unit? It's exactly 1/12 of a carbon 12 atom. Therefore, hydrogen 1 atom has an atomic mass unit of 1.00794. Oxygen 16 has a mass of 15.9994 atomic mass units. Now, what are those values corresponding to? What are those values corresponding to? Any idea? Yeah. The atomic weight, if you look on your periodic table for hydrogen, and the little red number above the symbol, the atomic weight, what is it? 1.00794. What about for oxygen? What about for magnesium? should be 24.3050 atomic mass units. Okay? Now, what that atomic weight is doing is, we talked about different isotopes. It's adding up all of the isotopes and the percentage of those and getting a value for magnesium, so to speak. That leads us to the mole. The mole. What is a mole? A mole is the SI unit for the amount of a substance. We abbreviate the mole MOL. It's not really a great abbreviation. You're only losing one letter, right? But nonetheless, MOL is how we abbreviate the mole. The mole is the amount of substance that contains as many particles as there are atoms in exactly one carbon-12 atom, 12 grams. So the amount of particles there are in exactly 12 grams of a carbon-12 atom. Now, this might not make a lot of sense yet. Like, oh, there he is. Look at that guy. You know what that is? A mole. Is that the mole we're talking about? No, but we tend to associate our moles with that little fella there. Okay. What do you think he is? Look at those big claws. He's a digger. He's a digger. All right, now, let's relate this mole. Okay? We can't see what a mole is right now, but let's look at it in terms of a dozen. Okay? If I would say, I'm going to go out and get a dozen donuts, how many donuts am I going to get? 12. So 1 dozen is equal to 12 donuts. What if I were going to get a dozen ear of corn? I would get 12 ear of corn, right? What if I were going to go out and get 3 dozen donuts? How many donuts would I get? 36. Okay? So that's very similar to the mole. Okay? We don't count as 12 or 24 ear of corn or donuts. We label them as dozens. Could I go, let me ask you this, could I get 1.75 dozen? Yeah, I could figure out how many donuts that would be, right? Yeah, so I could split it up. That's the same thing we're going to do with moles here. So, we say, I want a mole of carbon, I want a mole of oxygen, or I might need 2.54 mole of iron. Now, just like the dozen represents a certain amount of donuts, the mole is going to represent a certain amount of iron, a certain amount of carbon. And what is that amount? Well, that leads us to Avogadro's number. Avogadro's number is the number of particles in a mole. Avogadro's number. You're going to learn to love Avogadro's number of particles in a mole. The best modern value given for Avogadro's number is 6.022, times 10 to the 23rd. Now, is that a big number or a small number? That's a pretty big number. So, it would take that many carbon atoms to make up 1 mole of carbon. So, you're going to want to count out a mole of carbon. If you could hold an atom in your hand, Justin, would you want to count out 6.0221367 times 10 to the 23rd of them? That's a lot of them, isn't it? So this is a very, very big number. Now what does that mean? We're going to base these all on carbon, folks. What that means is that exactly 12 grams of carbon-12 contains 6.0221367 times 10 to the 23rd carbon-12 atoms. And that is equal to 1 mole. So if I would count out all of the carbon atoms, I would get 6.022 times 10 to the 23rd. Right there. Here on my scale is a black substance, that is carbon. What's my scale reading? 12. Okay? 12 grams of carbon is equal to what? 1 mole. So that is 1 mole of carbon. How many carbon atoms are right there? 6.022 times 10 to the 23rd atoms. Now, why is this called Avogadro's number? Amedeo Avogadro, 19th century Italian scientist. So we've named this number, this 6.022 times 10 to the 23rd, we've named this number after Amedeo Avogadro. It's his number. And I found one of these little funnies on the internet here. Okay, this has been, what was that song? So here's my number. Call me, baby. I just met you, and this is crazy, but here's my number. So mold me, baby. And look at that Avogadro right there. Okay. Now, the point is, Avogadro's number, we tend to use this. We don't use the whole long thing. We round it, and we round it to 6.022 times 10 to the 23rd. Avogadro's number. So call him, baby. Avogadro's number is the number of particles in exactly 1 mole of a substance. We just stated that. So if I look at this, we're going to do something different. We've been talking about carbon, right? We've been talking about carbon. Well, let's talk about water. Okay? Let's talk about water. If I would go through and add up the mass, the atomic weight of water, okay, we know it is H2O. What's oxygen on your periodic table? 15.9994, right? What's oxygen? Excuse me, what's hydrogen? 1.00794, right? So what if I would take the mass of 2 oxygens. And then add to that the mass of one oxygen, and I'm going to get the number 18.01528 AMU, atomic mass units. Now, on my diagram here, I have that rounded. I have it rounded. So, one molecule of water has an atomic weight of 18.0 AMUs. How did I get that? I added 2 hydrogens with 1 oxygen from my value on the periodic table. Wasn't too tough, was it? We can add, right? Now, that is one molecule of water. If I had Avogadro's number of molecules, I would have how much water? 1 mole of water. So in this beaker, I have measured out, okay? What I've done, if you look, here's my atomic mass units, it's 18. How did that translate into the mass of 1 mole of water? What was it? 18 grams. So I've taken the number of AMUs, and to determine the number of moles, the mass of 1 mole, I've just said, okay, 18 AMUs, 1 mole will weigh 18 grams. Now, how many particles, in this case molecules, how many molecules are in 1 mole of water? Here's a key point. How many molecules are in 1 mole of water? What is that? What's that number right there? Yeah, what's that number? What do we call? What do we name it? Avogadro's number. So, in 1 mole of water, we have Avogadro's number of molecules of water, which is 6.022 times 10 to the 23rd. What did we say we had in 1 mole of carbon? 6.022 times 10 to the 23rd atoms of carbon. So 1 mole of any substance is equal to what? Avogadro's number, 6.022 times 10 to the 23rd. It could be atoms, it could be molecules, it could be formula units. Right here I have some different substances. Let's start all the way over here. I have 1 mole of C12H22O11. I have a mass, 1 mole of that weighs 342.3 grams. I believe that's sucrose. Here's something we're pretty familiar with, sodium chloride. 1 mole of sodium chloride is 58.4 grams of sodium chloride. Now let me ask you this. In terms of Avogadro's number, how much sucrose is here? It's 1 mole, so how much sucrose is there? 6.022 times 10 to the 23rd. In this case, it would be molecules, because that's covalently bonded. Right here, in terms of Avogadro's number, how many formula units of salt are there? HCl. 6.022 times 10 to the 23rd. Here's carbon. We've already dealt with carbon. 12 grams. So that is 1 mole of carbon. How many atoms of carbon are there? Avogadro's number, 6.022 times 10 to the 23rd atoms. Here's copper 2 sulfate. 159.6 grams make up 1 mole of copper 2 sulfate. How many formula units of copper 2 sulfate are right there? Avogadro's number. So each one of these are Avogadro's number because they are 1 mole. What if I would tell you, let's just look at carbon because it's going to be the easiest. What if I would tell you that there are 2 moles? What would my weight now be? Can I double that? Sure. So what's 12 doubled? 24, right? What if I would say there was 1.5 moles? Okay. What's 1.5 of 12? 18, right? I have 12. Half of 12 is 6. 12 plus 6 is 18. So I can do that, right? I could do that. Now, what if I were talking about Avogadro's number? Could I multiply Avogadro's number by 1.5? Could I take 6.022 times 10 to the 23rd and multiply it by 1.5 to get a number? Yeah. Yeah. And would that be equal to 1.5 moles? Yeah. Yeah. Now, I said this a little earlier, but for most purposes, Avogadro's number is rounded to 6.022 times 10 to the 23rd. Now, that leads us to stop my little video right here.